So today we're going to take a look at a little bit more of the range formula and some other projectile motion problems. So let's take a look at this one. A ball is kicked 50 meters, so it goes downfield 50 meters. And we know the launch angle, or not the launch angle, but we know the initial speed is 24 meters per second. Now, because this is level to level, we're kicking it down a field, we can use the range formula. So range is v squared over sine of 2 theta over g. Now it wants the launch angle, so we're after the theta. So what we're going to do here is we're going to rearrange this. We're going to have rg over v squared is sine of 2 theta. Now at this point we can substitute. So the range was 50 meters. Gravity, of course, is 9.8. And v was 24, but we don't forget to square it. And then we get the sine of 2 theta. Now let's see what that works out to. Times 9.8 divided by 24, and I put it in parentheses, squared, is 0.851. So to get the 2 theta, you have to excuse me, I got to get my pen back on here. There we go. 2 theta is the inverse sine of 0.851. So we're just going to take the second sine of 0.851, and I get 58.3 degrees. But to actually get the theta, I've got to divide by 2. So let's see what that works out to. 29.1 degrees. But there's another angle. And the other angle is the complement. It's 90 minus 29.1. Which is our 60.9 degrees, just like we see up there on the slide. So why do we get two angles? Just to review, we could hit it at a low angle, or we could hit it more like a pop fly at a high angle. Now to get the maximum heights, I'm going to need some room here on my slide. So let me clean all this writing off. You can always go back and look at it if you want. And let's see what's happening here. So let's do the 29.1 degree over here and the 60.9 degree over there. So what we have to do is we have to find the x and y components, Vx and Vy. And we know it was 24 meters per second. So we're really only interested in the Vy, but we'll find the Vx as well. So Vx will be the hypotenuse times the cosine of 29.1 degrees. And it's cosine because it's adjacent to the angle. So that's 21 meters per second. Vy, we'll have to use the sine. And that's 11.7, excuse me, meters per second. Now to get the maximum height, well, we'll use the time independent. Oops, V final squared minus V initial squared all over 2y. A nice thing here is, we're thinking about this ball going to the maximum height. At the tippy top, at the peak, V final will be 0. So what we get here then is A is negative V initial squared over 2y. And if we solve that for y, we get negative V initial squared over 2a. I know there's a negative there, but that's going to go away. Now the question is, well, which V do we use? We want the y component, because that's what's making it go up into the air. And you'll see that the negative goes away because they're both negative. So 11.7 squared divided by 2 times 9.8, which is 19.6. And we get a peak of 6.9. I'm getting 6.95. I got 6.98 there. That's close enough for right now. It's probably a rounding issue. Now, similarly, for the 60.9 degrees, and I hope I left enough room on the slide, we'll see. We need Vx and we need Vy. Again, the launch speed was 24. So Vx is 24 cosine of 60.9 degrees, and Vy is 24 sine of 60.9 degrees. And that's going to be important because we're going to use that a lot in the next problem as well. 24 cosine 60.9 is 11.7 meters per second. And you're going to notice something neat with the what the numbers do because they're complementary angles. They just switch. And then I'm not going to rederive the formula for a second time because I know what it is. This time also, we take the y velocity. X and y are independent. We can't say that often enough. So square that, divided by 19.6, which is 2 times 9.8, is, yeah, I'm getting the same number there, 22.4, and that's fine. So that's that problem. Now we're going to move ahead. I'm going to skip this fireworks one for right now, because I really want to be able to spend some time on this football problem. So football is kicked at an angle of 37 degrees with a velocity of 20 meters per second. So we want the maximum height, the total time the ball's in the air, how far the ball travels, velocity at the highest point. Oh, a lot of information here. Now when we do these problems, we split them up. We think about the time up, and we think about the time down, and we do that separately. Now, let's get a clean slide here. I think it'd be a good idea to have a clean spot to work here. So let me just put a clean slide in here for us to work on. And put the pen back on. There we go. So let's check. First thing we got to find is the maximum height of the football. So I'll do some of it on this slide, but eventually I may need more room. The first thing we have to do is figure out the Vx and the Vy. So 20 meters per second at an angle of 37. So Vx will be 20 cosine 37 degrees, and Vy will be 20 sine of 37 degrees. And then let's figure out what those are. And they work out to pretty nice numbers. So Vx is 16 meters per second, and Vy is 12 meters per second. All right, now we can go ahead and get the maximum height of the football. Maybe we'll use, again, time independent. And remember, we're just looking at when it goes up. At the tippy top, Vy will be 0. So just like we previously saw, we're going to rearrange this equation and get that equation, and now we're going to substitute. But we have to use the y velocity because the maximum height is a y velocity. And somebody's backing up outside. I apologize. You're getting real-time instruction here with all the street noise. 12 squared, which is about 144, divided by 2 times 9.8, 7.39, 7.35 meters. Okay, that's pretty good. Let's see, now we want the total time the ball is in the air. So that's part B. So we'll use definition of acceleration. But again, we're thinking about just till it gets to the tippy top. So V final will be 0. So acceleration is negative V initial over t. T is negative V initial over A. Of course, the question is, well, which V initial? It's going to be the 12. Because that's in the y direction. So that's 1.22 seconds. But that's only time up. You'll notice that's half of what the answer I gave. So to get the time total, we did this before in the last chapter, we just double that number. Because it's level to level, time up will be equal to time down. So that's the total time that it's going to be in the air. Now let's see what we want to do. Horizontal and velocity at the highest point. Now in the horizontal direction, the speed never changes. So Vx is distance over time. There's no acceleration in the x direction in these problems. Gravity only works in the y direction. So it just becomes Vx over t, or 16 times 2.44. And let's see what that works out to. 39 meters, and I believe that's the correct answer. Now D says, well, what's the velocity at the highest peak, at the peak here? At the peak, Vy is 0. It's not going to go up any higher. You know, football only goes so high. But it's important to remember that it's still moving horizontally. So it does have a horizontal velocity. Its velocity is 16.0 meters per second, or we might even say 16.0 meters per second I. And then E wants the acceleration. Well, we can't turn off gravity, so the acceleration is negative 9.8 meters per second squared.